Hello, folks. Welcome to Rational Science, the only site on the internet that does physics at all. Everybody else does mathemagics. Anyways, I'm still on the road, and I'm going to be starting today with the main course instead of with extinction. We'll do extinction later on. And what are we going to talk about today? Well, we're going to talk about these folks, okay? And they're crackpots. That's what they are. They're crackpots. Why? Because they have been shunned by the string theorists who apparently have taken over. It's the string theorists who now dominate the game. Okay, they're the ones who run the show. And anyone who's not a string theorist, well, gets pushed aside and doesn't get any funds and doesn't get his name in lights and probably will not get a Nobel or anything like that. And the first three on the left there, those are all Nobel Prizes. Okay, they all won Nobels. The ones on the right are just somewhat famous, okay? And there's a lot more of them, right? I've been covering them over the last couple of years. But I'm going to be covering primarily the two above there. Eric Weinstein and Sabine Hassenfelder. And she's a neighbor of mine. She lives in Frankfurt, a little up north of where I live. And she's against string theorists or string theory. And so are all the guys on the right. And that's part of the problem. Part of the problem is that string theorists, which is just pure mathematics, I guess you could say, or like they say, has nothing to do with physics, the people who are against it. In fact, even the people who are string theorists, they say it's got nothing to do with reality. So the question is, what are these people studying? What is all this math for, And that's part of the problem. It suggests that, there's some kind of crisis in physics, and that because of that, there's this schism between the people who are advanced and do string theory. You can say they're advanced in the sense that they're doing some sophisticated mathematics, and compared to the other people who are, still hanging on to quantum mechanics and general relativity. That's essentially the situation. And you can say this starts all sometime back in the 17th century, when the so-called scientific revolution began. Okay, and you had these gentlemen. Okay, you have William Gilbert, Galileo, Torricelli, and these people not only did math, but they started doing experiments. They said that what was missing in the Greek culture, in what the Greeks passed on to the West, was experiments. Okay. So Gilbert did magnets, Galileo did mass, worked with rolling balls apparently. Torricelli did vacuum, Boyle did vacuum as well, and so on. You might say, how come I didn't put Hooke's face there? He looks all black. Was he black? No. The reason you don't have a face there is because that fell down on the bottom. His name is Newton, Isaac Newton. When he took over the Royal Society at the beginning of the 18th century, the first thing he did was destroy anything related to Hooke, including any pictures that he had. They were mortal enemies. Okay, Hooke accused Newton, like Leibniz also accused him of plagiarizing, and so they had their run-ins. And so when Newton got up there, he made sure that nothing survived from Robert Hooke. Anyways, these fellows started doing experiments, and that's more or less when the problem really started, okay? Because on the one hand, we had these folks doing experiments and doing math, and that's what they thought science was. That's how they were going to figure out how this universe works, okay? And here you have synthesis from Mr. Galileo himself, and he says the following. He says, the universe, we cannot understand it if we do not first learn the language. What language is he referring to? In which it is written, the book is written in mathematical language, without whose help it is impossible to comprehend a single word of it. Mathematics is the language in which God has written the universe. And you can see the notion that he had about experiments. I think that in the discussion of natural problems, we ought to begin not with scriptures, but with experiments and demonstrations. And yeah, he was wrong on both counts and set off the whole world on the wrong path. He wasn't the only one. All these people believed in the same thing, experiments and math. Turns out that, here we have a spoon, okay? And we let go of it. Okay, it falls to the floor. And we've known this trick for thousands of years, and nobody can explain it. And, there's no math and no other experiment that, that will elucidate what's causing this to fall to the floor. And there's only one way to elucidate that, the cause, the mechanism, and that is to visualize, because you can't really run a test, you can't go to a lab to do this, but to visualize what invisible, intangible entities are in contact with the spoon. That's all they had to do all these 10,000 years. And instead, they did math and they did experiments, and today nobody can tell you why a spoon falls to the floor. That's how ignorant our mathematicians are. They do a lot of math, they do a lot of string theory, a lot of quantum, and no one can tell you why a spoon falls to the floor. And why? Because they've never identified the notion that you need to find out what invisible, intangible entities are out there that Mother Nature and Father Universe use every day to do their tasks. And if they would have done that, it's kid stuff then. Once you visualize the invisible entities, then, explaining gravity is kindergarten stuff, baby stuff. Okay, so we can go back to the 17th century, but let's go back to the 19th century where another phenomenon happened, and that's when when these fellows came into being. I call them the 4 F's and M. Fresnel, Faraday, Fizeau, and Foucault. And Maxwell, the Scottish guy there, right? And primarily, I guess it would be Maxwell who kind of synthesized it all from a mathematical point of view, the description, okay? And what he came up with is, or they in general, because they were all dealing with the waves, transverse waves, they came up with this, the electromagnetic wave. And I should add the irrational electromagnetic wave. You might say, Bill, what do you mean? What's irrational about it? Okay, let's stop it. Let's stop its motion. Okay, that's what we're staring at. Okay, that's the electromagnetic wave standing still now. And the question is, what are we staring at? And you see all these little lines, looks like engine arrows, right? And so let's take a look at what we're staring at. Let's analyze what we're looking at. We're looking at this. We're looking at what is called an electric field and a magnetic field. We have fields, okay? And that word was invented by Faraday up there, okay? And so we have these fields. And what are they made out of? Well, they're made out of vectors. So we have, they're not engine arrows, they're vectors. And what is a vector? What is a field? Well, let's find out. These are the definitions you find in the dictionary today. Field, a physical quantity that has a value for each point in space and time. So what is a field? Well, it's a number, a bunch of values. That's what it is. That's all it is, And physical quantity, a property of material that can be quantified by measurement. Again, it's talking about quantities and measurements. Okay, that's what they say a physical quantity is. And what is a vector? Well, it's a geometric object. Obviously, it ain't, right? No, it's not an object because it doesn't have any shape. A vector is one-dimensional, according to the official version. It's just a little stick, a little line that they draw, a two-dimensional line to represent a one-dimensional concept known as a line, right? And so it's not geometric because there's no geometry that's 0 or 2 or one-dimensional, okay, or four-dimensional for that matter. And it says that it has magnitude and direction. Magnitude belongs to math. Direction belongs to physics. Direction is a qualitative concept, has no place in math. They say, well, when you have acceleration, especially angular momentum, well, then you need to have, because it could be two ways. You could accelerate by increasing your velocity, or you can accelerate by changing, the direction in which you go. But see, direction is not something you can put in an equation. Okay, that's the issue. Okay, so what do we replace this concept with? Because what you're staring at is a pictorial representation of a concept, of a mathematical concept, and it's defined as concept. The field, the physical quantity, vector are all mathematical concepts. Okay, and so you don't have a physical object yet. We're not doing physics yet. So when they say a wave moves and does this and that, you're not talking about physics. They're talking about this thing, which is a mathematical concept, which they pictorially represent with that image there. And people think, especially when it moves, you have these vectors, these numbers that are moving, numbers in direction, right? They're moving, quantities in direction. And people think they're looking at a thing, and they're not. That's not a thing that you're staring at there. It's a mathematical concept. And that's what's so misleading about what we learn in high school and college, right? So what do we replace it with? Well, here we're going to replace it with what we needed to replace it a long time ago. And that's with a rope. As you can see, the rope and the wave, so-called transverse wave, the two-dimensional electromagnetic transverse wave, to use the whole, phrase, right? As you can see, they have the same structure. They have the same architecture, the same configuration. Okay, they're both DNA-like. Okay, and you can see what they've been analyzing or describing for over 150 years now. They've been describing a rope, but they've thought it was a wave, something that's moving from A to B. And that's not the case. What you're seeing there is something different. A rope, first of all, meets all the conditions of a wave, right? If you have a tight rope, right, very tight, the two threads there embrace or hug, an axis. That's one issue. The other one is that, you don't have arrows. What you have is actual threads. You have physical threads. That is physical. What's on top, that's not physical at all. The fact that you can measure does not make it physical. Okay, but that's what they call physical. And so, let's put it in motion. Let's see if we can find out what's different about these two proposals, right? And there you see the electromagnetic wave. It goes only one way, okay? Whereas the rope, it twirls in situ, right? It twirls in situ, goes nowhere. Each link essentially stays where it is, and what you have is a push at the two ends. Okay, so electromagnetic rope is bidirectional, travels in opposite directions simultaneously, even though it doesn't travel at all, but it gives a thump, at the opposite ends, and that's the notion that people have of the particle, the fact that it's thumping, it's twisting the atom that's at the opposite ends. Okay, but it's a totally different concept, because here you have the electromagnetic wave only going in one direction, whereas the other one twirls in place and goes in both directions, you could say, right? Then you have the fact that the speed, if you take an electromagnetic, you take any wave, any longitudinal wave or any transverse wave, and they're slow compared to the fastest thing anyone can imagine. And I challenge anyone to imagine anything faster than a rope. Rope twirls in place. That torsion, right, is already at the opposite end. That's how fast it is. Okay, and so that's why the rope model can explain at least the speed of light, right, among other things. But it can explain the speed of light, and it can explain why light travels in a straight line, never curves, like in general relativity, right? It never curves. It goes from atom to atom in a straight line. It's always taut. It's not that it's straight. It's really pulled taut, okay? Tight. Okay, that's what it is. And that's why it's straight. That's why light can only travel along the rope, you can say, and always in a straight line. Okay, it has no possibility of getting lost. Okay, so what we want to show here is that what's on the opposite sides, because you don't see where the wave is coming from or where it's going. You don't see what's happening to the rope. So let's show that now. Okay, here it is. Okay, what you have is in quantum mechanics, what you have is you have this atom, which is a ridiculous atom. It's an irrational atom. And you say, well, why is it irrational? Well, you can see that blue ball, that's known as the electron, right? The electron bead. And it just falls from one orbital or energy level to another. It goes back and forth, okay? And when it does so, when it falls, it releases something they call energy. And when it rises, it absorbs energy. The atom absorbs this thing called energy, light or whatever. That's how light is produced according to the quantum mathematicians. And so that's on the one hand. And then here on the bottom, what you see is the other model. Two atoms are permanently bound by the electromagnetic rope. And the rope does convert into the atoms themselves. Okay, each one of the threads goes into and makes up this balloon, this membrane that encapsulates the star, the proton star that's inside it. So it's a total different model, but what you see is the quantum jumping of the atoms. The atom is a tiny heart pumping torsion waves, known as light, to every atom in the universe. Okay, so these electromagnetic waves are really torsions of the rope. That's what it is. That's the suggestion. Okay, and yeah, you can see the model is totally different. But you know, one of the problems with the quantum model is that why doesn't the negative electron bead fall to the positive nucleus, as it's known? You know, they say the proton is positive, the electron is negative. Well, when it falls, why does it stop at the energy level? Why doesn't it continue rolling all the way to the center of the atom? Or even worse, why doesn't it just fly away by centrifugal motion? You know, if it's rolling around, why doesn't it just fly away spontaneously? And that's the whole problem. You know, they have an irrational atom that they cannot explain. And with this atom, they're going to explain, you know, ionization, electricity, bonding, etc. They're gonna try to explain with this irrational atom. They're going to try to explain how this micro world works, and of course they fail miserably. They cannot explain it. Okay, so that's where the problem starts with the electromagnetic wave. There is no such thing as an electromagnetic wave, and that's what none of these folks since the 19th century ever realized. You can't talk about waves. Wave is a verb. Wave is what something does. There is no physical standalone object called wave. In the ocean, it's called water. Okay, water is the thing, and wave is what it does. Okay, flag is a thing, and wave is what it does, and so on down the line. So you can't say the wave waved. You can say the water waved. You can say the flag waved. You cannot say the wave waved. Okay, and that's what they're saying essentially. They're treating wave as a noun, as a subject of a sentence, as a thing, which it ain't. Okay, and so here we have a comparison between the two. Okay, so here you have more or less a synthesis of what's wrong with the quantum version. You have these vectors, which are those arrows, right? And those are mathematical concepts. So they represented a mathematical concept with an arrow. That's what they did. And then they have these sets of arrows, one called the electric field, the other one the magnetic field, and they run at 90 degrees to each other. No one knows why. Okay, with a rope, it's very simple. You know, you take any rope and you'll find out that one thread goes 90 degrees to the other thread by its own structure, by its very structure. And we're not talking about fields, we're talking about threads. Field is a concept, thread is an object. There's a big difference between them. And whereas the torsion travels bidirectionally and at the speed of light, the transverse wave travels very slowly. And we know this because when there are earthquakes, the longitudinal waves that propagate, during earthquakes travel 1.7 times faster than the transverse waves produced by the same earthquake. And you would think that that's the case because the longitudinal wave just goes back and forth along an axis, where the other one has to jump up and down. So yeah, hopefully transverse wave is the slowest wave known to man. And if that's the case, it's very hard to think that light consists of the slowest wave. Probably consists of the fastest wave, which is a torsion wave, 3D torsion wave, not a 2D transverse wave. And then there at the bottom, you see why the velocity of light is a constant. Little c there, which is 300,000 kilometers per second, is equal to frequency times wavelength. If the frequency goes up, the wavelength goes down, and vice versa. How can you explain that? Well, with a rope, you can explain it very simple. Just take any ordinary piece of rope, meter length if you want, and torque it. And the more you torque it, the smaller the links become and the more links you have. More links, frequency. Smaller links, wavelength, or link length, really. So it shows you why the rope is the proper model. The only entity that can imitate that equation, which is the wave equation for light, and explains or justifies the speed of light, is a rope. That's the only thing that can justify it. It's the only architecture, the only configuration of matter that we can imagine that can simulate light, electromagnetism. Okay, so how do we construct our atom? Well, we construct it like this. Here it's going to start. Give it a second. Here you have the electric thread and the magnetic thread. The electric thread goes right through the center of the atom, and all the electric threads from every atom in the universe converge upon our atom. The magnetic threads from every atom in the universe come around and form the membrane that encapsulates the proton star. Okay, so that's what we're showing there. That's the notion. Okay, and here you see our atom. You can see the ropes dying at the electron shell, and what continues are the single threads, the electric threads, right? And electric and magnetic are just to keep with convention, so we use the same nomenclature only because of that, okay? But there you can see the electric thread going through the center of the atom. The electron shell is built by the magnetic threads that go around. There's no difference, by the way, between electric and magnetic threads. It's all part of a single thread, okay, in the universe. And there you see the ropes converging on our electron shell, and then only the electric threads continuing to the center of the atom. Okay, so that's what we're showing there. And if we show you here the picture of standing still, here it is. This is more or less what we're talking about. We're saying you have these electric threads from every atom in the universe coming to our atom through these ropes. The ropes end at the electron shell. What continues is one thread that goes through the center of the atom and the other thread that goes around and encapsulates the proton star. That's our atom, okay? So every atom in the universe is bound to all other atoms in the universe because they're all interconnected by electromagnetic ropes, not waves, but ropes, okay? And so you get a picture of what we're trying to say here, at least, a basic picture, And here is what we say that's the only thing we have in the universe. See, according to quantum mechanics and general relativity, the universe is just filled with particles. That's all that a mathematician works with, discrete particles, okay? So all they have is these particles, and they say, well, they're also made of fields and energy. But when you look at energy, they say, well, those are particles. And what is fields? Well, aside from vectors, they're also particles. So fields are made of particles. What is a particle? A number. That's what a particle is, a value. They measured something and they found out what the strength is at that point, and the summary, the aggregate of all these numbers, that makes up what they call a field. So no matter whether you use the word field, the word energy, whether you talk about space-time, point in, what's space-time? Well, it's made of events. What's an event? A point in space-time. So they only have little points. What are all those points? Numbers. So it's all mathematical. It has nothing to do with physics. Okay, none of what comes out of mathematical physics has anything to do with physics. And so, yeah, here we have the two versions. We have the mathematical version, which is just a bunch of particles. And we're saying that what we have out there is not that space is filled with particles to infinity, as some say. No, there's a single thread, closed loop thread out there in space. And that's all there is. And space is that which has no shape, whereas the thread is that which has shape. Thread is an object, whereas space is not. What is nothing? Nothing is that which has no shape. What is something? That which has shape. So we can use these words consistently and make sense of our universe. And there it is. And obviously, the thread was always there. It wasn't made. You know, it's eternal in both directions of time, past and future, right? And so, yeah, we have a very different universe than the one promoted by mathematical physics, which is, you know, that the universe did have a beginning, that matter did have a beginning, that space itself had a beginning. You know, God made space. How he made nothing, I don't know. Or maybe that's the easiest thing to make, you know, when you do nothing. I'm going to make nothing. That's what God said. Let there be nothing. And nothing was there. Let there be nothing. Okay, so the single thread, right, turns into, you know, again, it's not that there was an evolution. The universe has always been atoms, all interconnected. But if we were to disassemble the whole thing, we were untie every knot, every atom in the universe, we would end up with a single thread. Thread starts somewhere and ends at the same place where it started, you know, and so it's a closed loop thread. And from there, you can see the model right at the bottom, the rope connecting two atoms. You have the 2D and the 3D version there. And what are we seeing? Well, we're seeing a quantum jump. And by quantum jumping, it torques the rope, and that's what we call light. Okay, so the model, I think, is easy to understand. It's baby stuff, kindergarten stuff. The universe is baby stuff. Father Universe and Mother Nature never went to school. They never learned math. Okay, like good old Galileo said, you know, the language is math. No. The language of the universe, the language of physics, is illustration. If you cannot illustrate it, you're not doing physics. Okay, you don't have a theory of physics, because physics cannot do without an object. That's the golden principle, as I call it, of physics. Physics requires an object. He who does not use an object, who uses concepts such as field and energy and mass and time, he's not doing physics. Okay, they're doing math. But they present it in the guise of physics. That's what's happening. Okay, one fellow says, some details about the rope model are unclear because you never delved deeply into it. But it would be nice if you talked more about the rope model in your videos without necessarily comparing it to the catechism of mainstream science. Well, all I can tell him and anybody interested, you know, I have this book. Okay, it's a free book. You don't have to pay a cent for it. It's in the description there. Look it up, the rope hypothesis, and it'll take you to my website. You can download it. You can look at it on the internet. You know, it's a PDF file, 170 pages, heavily illustrated. I think every page is illustrated more or less. I think most of them. I don't think all of them are. But you can just understand the rope model by looking at the pictures. That's how simple the theory is. That's how simple Father Universe and Mother Nature are, you know. No math, no equations. We don't need that. Those are relations established by humans. You know, we saw circles and say, oh, there's a relation between the circumference and the diameter. That's us. You know, Father Universe, he doesn't care about that. He works with stones. He worked with asteroids, with moons, with Earth and other planets, stars, galaxies. That's his world. Okay, we are the ones who make comparisons. You know, Father Universe, he doesn't make comparisons at all. He can live without them. Okay, and so yeah, you can look this up. It's in the description. And if you want more insight, you want to go delve deeper. Well, there's a book, my first book, which was Why God Doesn't Exist, and you can find that also in the description. Okay, so anyways, so if you want more information, there it is. It's available, you know. And I can't cover everything, I guess, on the internet, even though I've covered quite a bit in the last few years, right? So, but, you know, it's a pain to go through all my videos. I got like almost 1,000 videos. Okay, so, well, that was light. Okay, here's gravity, just a very quick glimpse. Picture's worth 1,000 words. Video is worth 1,000,000 words. So here it is. Here are the 1,000,000 words, okay? There you go. How does gravity work? Well, every atom of the astronaut is connected to every atom on Earth. Okay, and so you know that's simply the way it is. Every atom of the astronaut is connected to every atom on Earth. Every atom on Earth connected to every atom of the astronaut. And so as he falls, you can see what's happening to the ropes that connect into every atom. You know, when he's very, very, very far away, all the ropes come together and act as a single coaxial. They're on the same axis. Ropes superimpose, okay? They never invented touch. And then as the astronaut falls, all the ropes start fanning out, and you have the acceleration of gravity there. There are more and more ropes the closer he gets to the center of the Earth. That's what it's all about. And here we can put that in a single picture in case you didn't understand, okay? Here it is. Let me show you this. This is a static version of that. Okay, you can see that when he's far away, all the angle of the ropes are closer together, and you can imagine at infinity, it's just a straight line. And as he falls, right, the ropes are fanning out. That's the acceleration of gravity. That's what they all missed. And you say, Bill, where did you get this ridiculous idea that all atoms in my body are connected to every atom on Earth and vice versa? Okay, so maybe you like authority. We'll put authority. I put him up in the past. Let's put him up one more time. Okay, why not? Here it is. This is Richard Muller from Berkeley University. So you don't say that I'm the guy who said it. No, here it is. This guy's going to tell you what the specification of gravity is. Okay, listen to the two specifications of gravity. What you need to explain if you want to explain gravity. Okay, here it is.
If you have the Earth with its big mass here, and you have you with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it. You're pulling on atoms right now on the other side of the Earth. There's a lot of atoms here you're pulling on. You're pulling on all of them. The amazing thing about gravity is it goes right through things.
Okay, so we have to explain why every atom on Earth is connected to every atom in your body, and why one atom of your body is connected to every single atom on Earth. Well, how are you going to do that? Are you going to do that with warped space-time, warped number lines? Is that how you connect every atom in your body to every atom on Earth? Okay, so hopefully if every atom in your body is connected to every atom on Earth, they're physically connected. And if they're physically connected, there had better be some elongated object connecting one atom with the other. Otherwise, you're doing black magic. You're doing witchcraft, which in science they call action at a distance. That's a scientific term, okay? Please. It's action at a distance. You know, remote control. That's what it is. And so they say action at a distance. No, there is no action at a distance. It's that you cannot see or touch the mediator. An elongated mediator, hopefully, because, I mean, if one atom is on the moon, the other one's on Earth, there had better be a single elongated mediator connecting those two atoms, according to this gentleman. The other thing you got to keep in mind, you know, the gravity goes through things, meaning the rope, in this case, right, goes right through one atom to another atom to another atom. If they're all on the same line, you know, they're all connected on that same line. It's like a tug of war between 2 points, right? And all the ones in the center, they don't count because they're really not pulling. What you have is tension. But that's a little harder to explain. The best thing is, again, go look at my book, The Rope Hypothesis, and it'll give you an idea of what I'm talking about. Okay, so let's move on here. So far, all I said, hey, where the problem is. The problem is the wave is a serious problem, not to mention the particle, which ain't a particle. The particle is a number. That's what they mean when they say particle. It's a value. It's a value with a unit. It's got nothing to do with physics. Got to do with math. Okay, but the wave, they put it out there like if it was a thing, and it's not a thing. It's a rope that you're staring at. This is the architecture of light. It's a rope. Okay, you can see why it's undulating. You can see why it is structurally wavy. You can see why it embraces an axis, right, that runs through it. And you can see why the electric thread runs 90 degrees to the magnetic thread. Okay, so yeah, DNA imitated the rope, I think, and so did collagen and some of the other things that give us life, that underlie the structures that give us life, or that are involved with life. Proteins and DNA and all these things. They're all twisted. They're all ropes. They all have these torsions. You got to look at it. These helical structures. Okay. So we thought we had it all figured out. What is it, 1920s? By 1927, actually. And here you have it. We have Heise and Born, these two fellows, and they said, we regard quantum mechanics as a complete theory. It was done. We're finished. Over and done with, right? For which fundamental physical and mathematical hypotheses are no longer susceptible of modification. Okay, and they said that in 1927 at the, I think they said it at the Solvay conference in Solvay in Belgium. And yeah, so it was a done deal. Why? Because the equations were already out there. Schrodinger's equation was there. Heisenberg's equation was there. Heisenberg's equation, you should know that. It's easy from a qualitative point of view. It says that when this ball moves, right, it's moving, it doesn't stand still. And when it stands still, it doesn't move. That's what Heisenberg proved mathematically. He won a Nobel for that. When the ball moves, it doesn't stand still. That's what he said. The more you know about position, the less you know about motion or momentum or whatever. It doesn't matter. And the more you know about momentum, position, motion, displacement, the less you know about position. Yeah, it took a mathematician to prove that. Jesus. Okay, and so we've come a long way since then. Right now we haven't figured out anything. Especially they haven't figured out gravity, especially in quantum mechanics. So they invented this thing called quantum mechanics. They have all the equations. They have more equations than what they need, and they still can't figure out anything about quantum mechanics. They don't know how this universe works. They don't know how the micro world works, the subatomic world. They have no idea whatsoever. All they've done is invent particles, actually names that they've given what they think are particles, the muon, the pion, the bosons, a lot of them in the circus, a lot of bosons over there. And so all they've done is just give names to these things, but they have no idea what they're looking at. Okay, it's all invisible to them. And right, because, you can't see the rope, and the rope is invisible and intangible. Hopefully, if you go to the lab, you will not be able to touch it or see it, because if you can, well, then you would not be discovering Mother Nature's universe, because hers is invisible and intangible. So what you have to do is imitate her universe, not the one you want. You say, oh, I touched the rope, I touched light, no, you can't. Okay, you can't touch the mediator. Okay, you can pass your hand right through it. Right here we have gazillions of ropes in this room, and I'm passing my hand right through the ropes. Okay, and that's very counterintuitive to a lot of people out there. And yeah, of course we have answers for that, but for that we need another day to answer those questions. Okay, but here we have today, we have this fellow, and he's complaining about, what these people are complaining about is not only him, but others. They're all complaining about the fact that string theorists have pushed them aside. It started out like, okay, you're going to do string theory, which is a little more sophisticated math, or some weird math out there. Okay, go do it. And so there were a few people, but that world has been growing and growing and growing and growing to the point that now they've displaced the people who do quantum mechanics, experiments, and general relativity and all that stuff. They're pushing them aside. Okay, they're taking over. It's the string theorists who have conquered the world of math. And that means that if you learn quantum mechanics somewhat in high school and certainly in college, if you took these courses, get ready. It's dead. It's not even dying, it's dead. You say, no, it's not dead, Bill. I mean, they've got quantum computers and, all this other. No, hold it. Let's get it right. Quantum started because you have Planck, Max Planck, he came up and he said it's a discrete particle. Okay, him and also Einstein, who came in a few years later, 5 years later, and he said, look, we're talking about this discrete particle. Light comes in discrete particles. They call them photons eventually, right? But the photon is dead because the photon is a discrete particle, and right now they're dealing with, on the one hand, string theory, which got rid of a lot of that, especially the word field. And the word field, what is a field? Field is this extended object that extends throughout the universe. And so what happens is you have this field, this extension, this extended thing, and locally it vibrates. And when it vibrates, they call that a particle. But see, that's not a discrete particle. That's not an island. It's a peninsula. Okay? Peninsula is not an island, and quantum is islands, not peninsulas. Okay? So what they've done is, they have these vibrations of the field, and they call those particles. It's a localized vibration. But that overrules quantum mechanics, which says that particles are discrete. So I don't know how they're going to put peninsulas in the standard model now. Okay, so here we have this fellow, and his name is Peter Voigt. And he says the following. He said this in 2001, talking about string theory, which started taking over, and he realized that, so he was already guarding against that. He said, graduate students, postdocs, and untenured junior faculty interested in physics beyond the standard model are under tremendous pressures in a brutal job market to work on the latest fad in string theory, especially if they are interested in speculative and mathematical research. For them, the idea of starting to work on an untested new idea that may very well fail looks a lot like a quick route to professional suicide. And it says, many physics researchers do not believe in string theory, but work on it anyway. Just act busy, get money and just do as if you're working, right? They're often intimidated intellectually by the fact that some leading string theorists are undeniable geniuses, and professionally by the desire to have a job, get grants, go to conferences, and generally have an intellectual community in which to participate. Okay? Funding agencies should question whether it's a good idea to fund a large number of conferences and workshops on the latest string theory fad. Okay, he said that in 2001. And guess what? He was pushed aside. Instead of them not spending money on string theory, they stopped spending money on research for quantum mechanics because quantum mechanics has made no progress really whatsoever. Okay, all they're doing is trying to figure out more particles and more particles. And what are particles? Just more numbers, meaning more equations. And we still don't have an understanding of how the micro world works. And so what are these people doing? They're wasting money. And so what does this fellow White come up with instead? Well, here it is, okay? Very important stuff. It's called the twistor theory, which he apparently stole from Roger Penrose. And they come up with this nonsense, and they call this the twistor theory. And I call them the twisted crackpots, both Roger Penrose, the Nobel Prize, and him, because you look up what this stuff is about, just in general terms, right? It says twistor space is the complex vector space of solutions, blah, 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 blah. And they go talk about solution. In other words, it's a mathematical thing, okay? And it has nothing to do with physics. It has a physical interpretation as what? As the space of massless particles with spin. Massless particles. We have particles that have no mass, but they have spin. They're nothing that is spinning. Great. And then My God. And twistor space is useful for what? For conceptualizing the way photons travel through space using 4 complex numbers. So it's just math. They call it twistor theory. They're describing with math, and it's math that is irrelevant math because it has nothing to do with reality. So yeah, these people are cranks today. They're considered cranks and crackpots by the new establishment, which is string theory. Okay, so let's keep that in mind. Okay, so these people are worried that math itself, mathematical physics, right, is dying. They call it physics, but it's math, right? And here you have this lady. Her name is Sabine Hossenfelder. Again, she lives north of where I live in Frankfurt. Right now I'm on the road, so I'm not in Frankfurt, but that's where I live normally. And this is what she has to say about this string theory thingy. Okay, listen carefully. Okay.
This is a typical academia story that illustrates so well what's wrong with the foundations of physics. It's that we're endlessly arguing about the same irrelevant questions. This is why physics is dying.
So she's saying that they're asking irrelevant questions. I guess all of them are irrelevant questions because they've never asked the right questions ever. And these are the questions they should be asking, which they never did, okay? And so I don't know what questions she's referring to, especially when they fight with the string theorists, but these are the questions that no one wants to answer, or they claim that it's not part of physics. And I'll let you figure out if any of them are related to physics, okay? So what causes gravity? I mean, is that a question of philosophy or of physics? They claim it's philosophy. Is light really mediated by what? Math quantities called particles? Is that something related to physics? 2D waves made of fields, made of vectors? How about wave packets? Okay? Are any of those related to physics? Then you have what causes a magnet to attract, repel another. And they never answer that question. You ask them, how does a magnet work? They have no idea. They say the electrons spin. So what? How does that create attraction between two magnets on different sides of the room, Does electricity consist of flow of charges called a flow of values called charges? They have these charges, which are supposedly electrons. They call them charges because they don't use the word electron because they're not talking about objects. They're talking about 1.6 times 10 to the minus 19 coulombs. They're talking about charges. All they're counting is math stuff. It's got nothing to do with physics. But they imagine it as a flow of little balls, little beads. That's how they illustrate it. And it goes from one end of the circuit to the other. That's how they visualize it. Sometimes they say, well, they're just pushing the next one over, so there's no real, it's not like the electron is moving from one end to the other. It's moving to the next atom, pushing the other electron out to another atom, and so on down the line. But, it's like a relay race, kind of, absolutely nonsense, okay? Electricity is not like they imagine it at all. Does the atom consist of an electron bead orbiting a proton bowling ball? They have this planetary atom, which they later deny. They say, well, that's not really our atom. And then that's what they illustrate. I mean, don't take my word for it. Just go to the Google images and put atom, like hydrogen atom, and see what you get. I think you're going to get what I always see, which is a little ball rolling around a bigger ball. You have the electron bead around the proton bowling ball. That's what you'll see. And then why doesn't this negative electron bead fall to the positive nucleus or fly away? They never answer these questions. These are the important questions of physics. Okay? If they're going to use that model of the atom, they should answer these questions. Can a particle be at two places at once, like quantum says? What sense does that make? What does that have to do with reality? I mean, we can go on, and these are just some impromptu ones that I came up with out of the top of my head. But you can see that these people don't answer these questions. Those are questions of physics, and they have no answers to that. They want to do math. They want to do equations. They want to do descriptions, not explanations. They don't explain a cause. They don't explain a mechanism. And, that's what people ask. People want to know, why does this spoon fall to the floor? That's what they want you to answer. And they say, well, let me tell you about black holes and holograms and who knows what else, parallel universes. Okay, so this lady continues. She says, string theory has nothing at all to do with reality. Listen carefully to her. I mean, she should know, right?
The situation is that either the theory is falsified or it's not falsifiable. It's exactly the same crap as with string theory and supersymmetry and inflation and dark sectors and many other research bubbles in the foundations of physics. It's mathematical fiction. It's nothing to do with reality anymore. I don't understand why people get paid for doing this.
Okay, let's see if we can go one step at a time. She says first what? She says falsified or unfalsifiable. That is the question, okay? That's an important question for her, whether it's falsification. She never learned that, whether it's falsified or unfalsified or it can be falsified or never falsified or whatever. That's an opinion, okay? A lot of people have falsified God. And a lot of people out there continue to believe in God. So falsification didn't work for them, So falsification is an issue of opinion. You don't falsify theories, not in science. In religion you do, but in physics, no. In physics, you explain. You explain something objectively so that people understand. Once they understand, they can reach their own conclusion and find out if it was falsified or not falsified. If it's truth or false, it's an opinion that every individual reaches on his own. Physics only deals with objective stuff, objectivity, and we don't use falsification at all in science. That's Karl Popper, who she apparently read and memorized and believes in, but it's got nothing to do with science. And here you have her say the next one, which is unbelievable. She says, string theory is crap. Okay, that's a good way of putting it, telling all the future bosses, because everybody's becoming a string theory. She's telling them, go to hell. Okay, I like that because, string theory is nonsense. It is crap. But the fact that she says it is interesting. She's so sick of it now that it's crap, okay? And then, so what do you get paid for doing QM and GR there, Sabine? She's doing crap too. She doesn't realize it, okay? What is quantum mechanics? Quantum mechanics is supposedly a little bead, the electron moving around a bowling ball. And they can't make that model work because, you can't tell me what physical entity keeps the electron bound to the proton. Why doesn't the negative bead fall to the positive proton? Why doesn't it spontaneously fly away? She can't tell me that. So she doesn't have a model to begin with. Then she uses either the wave or the particle model for light. Both of them are nonsense. She has no explanation for gravity. She uses the graviton probably, or maybe black hole, dark matter, some nonsense like that they've created. Invisible, heavy stuff. Conveniently invisible, conveniently heavy, right? And they do all this study with mass. They just say math with mass, right? They have only mass. And for everything, they just use mass. That's the only thing they use. It never occurred to them it could be some other factor working out there, like under the rope model. Okay, so this is in a way good that this happens to her, because she got paid for doing quantum mechanics and general relativity, throughout her life, and that was crap too. Just like string theory is crap. All of it is crap. All mathematical physics is crap. So we've had crap for 100 plus years, 150 almost. So I don't know what her problem is. She should come to realize that it's all mathematical physics is crap. And now it's at a crossroads where, if the string theories triumph, I think it'll be the end of quantum mechanics and relativity. That'll be relegated. Nobody will be writing about that. And these guys speak a language, a mathematical language that no one can understand out there. And so they're going to be a very small group, relatively small group, smaller and smaller as time goes by, whereas the rest of the world will not even pay attention to them because they won't understand squat about what these people are talking about. Okay, so this is what I say. If we summarize what she said, falsified, unfalsifiable, That is the question. Now, not in science. We have other more important questions. She says that string theory is caca. Well, I say that quantum mechanics and general relativity are also caca. You know, they're physical. They're fiction in physics. Okay, they have nothing to do with physics. And what does quantum mechanics says that string theory has nothing to do with reality? Well, what does quantum have to do with reality? A particle at two places at once, or general relativity? You know, the bending of number lines called time. You know, or like NASA says that the Earth drags time around itself when it spins. What nonsense is that? What does that have to do with the reality or with science, with physics? And so, yeah, I also don't understand how people ever got paid for doing quantum mechanics. But, yeah, that's the world we live in. Some people get paid for doing string theory. Others get paid for doing general relativity and quantum, which is also caca. Okay, and she finally says something else here. Okay, let's see what she says. She kind of bitches.
I recently heard Eric Weinstein say in a video that we're seeing the beginning of a collapse in the foundations of physics because it's so obvious now that string theory was a huge mistake. I think you're wrong, Eric. This will keep on going and going until physics is entirely dead. What we're seeing now is just that the senior people are handing over to their students.
I had to stop it there because I think she was going to start to cry. Well, no, what she doesn't understand is not physics that's dying. What's dying is mathematical physics, which ain't physics at all. Okay, that's the problem. And here it is. This is the roundup. What we're seeing is the collapse of mathematical physics, okay, which has nothing to do with physics, because it's so obvious now that quantum and relativity were huge mistakes. Those were the mistakes, okay. So I think you're wrong, Sabine. Mathematical poppycock will keep on going and going until we realize that equations are irrelevant tools in the context of physical interpretations, which is what people want to hear about, right? And that mathematical physicists have no qualifications or authority to tell the world how, meaning why, cause, mechanism, right? The world works, okay? And there you see a particle at two places at once. You see the bending of number lines. What does that have to do with reality? I mean, come on. We've been wasting time for the last 100+ years. None of that has any validity whatsoever. Okay, and here we have, just in case, there's a fellow by the name of Leonard Susskind. He works at Stanford University, and he's one of the prime movers of string theory. But it's important to listen to what he has to say, okay? Here it is, okay? But he doesn't say it. Someone who quotes him says this, okay? So take that with a grain of salt, okay? With a little, I think that's what he said because this guy is simply quoting him, but just keep that in mind. It's someone else saying it. But listen carefully. This is what supposedly Lenny, right? Susskind says. Here it goes.
This is Lawrence Krauss and Leonard Susskind, Susskind being one of the best theoretical physicists ever. Quote, I can tell you with absolute certainty, string theory is not the theory of the real world. I can tell you that 100%. My strong feelings are exactly that string theory is definitely not the theory of the real world.
So what are these people working on? We're spending money on these people. They're investing money in all these string theorists, right? And what are they doing? They're developing math and mathematical concepts on top of mathematical concepts on top of more mathematical concepts. Just a bunch of abstractions here. What is that good for? What are we getting out of that? I mean, and I don't mean technology. I'm not interested in technology. I'm saying, what are we understanding about science? What are we understanding about how the universe works with all this math? Okay, that they're developing. And that's the issue. The issue is, what is all this about? What are we spending the money for? What are these people doing every day, in their offices? And so, yeah, we have one fellow, and his name is Eric Weinstein. And I call him Whiny because he whines a lot. red wine, white wine. He does the whole works. He whines a lot, and you'll see him whining. And what he's saying essentially is, or his impression, this was from a September talk he gave or interview he had, where he says that string theory is reaching a dead end. He sees it in the opposite direction of Sabine. She says, these guys are taking over and they're going to drive us out. And he says, no, it's about to die. String theory is about to die because these people have not produced anything and maybe soon the funds will dry up. Okay, so that's his notion. And here, why don't you listen to him? This is what he's got to say about string theory in general. Here it goes.
We used string theory to cockblock actual progress in theoretical physics and derailed an entire field, at least in public.
Okay, so string theory derailed what he calls physics, which is quantum mechanics and general relativity, which derailed what used to be called classical mechanics. Classical mechanics is more or less rational mechanics, meaning they're trying to understand how the universe works. Quantum relativity got rid of all that. We don't understand anything now. And string theory is getting rid of these other two, and string theory is even worse. So we have worse taking care of bad, taking care of good, more or less. That's the situation. But this is what he's got to say, the same whiny guy, Weinstein. This is what he's got to say about what's happening with stringers, this war that they have going on, okay? Here it is. Listen.
The way in which it survives is by hunting and destroying its enemies and making its enemies dependent on them. We all have a circuit in our brain that we're going to run to the string theorists to talk about the problem with string theory because of peer review. And the problem is, look at how they treat everyone else. Everyone who is not a string theorist is covered and splattered in shit.
Okay, so I guess he's upset at string theorists because they treat him like quantum mechanics and relativists treat other people out there. They're getting a taste of their own medicine. Is that what it is? That's why he's upset? These people treat everybody, they're so arrogant because I studied math 10 years at the university. I know more math than you do. And with that, they put you down, then they continue and they say, we can interpret this world for you. And they come up with a description and an irrational explanation. And when you question that, they say, well, you're taking the analogy too literally. So they don't have an explanation for how the universe works. And now the string theorists are treating these guys, looking down on them kind of, and they don't like it. They're getting a little bit of their own medicine. That's what's happening. Okay, and so what does he recommend, this whiny guy? Whiny says all these stringers, they should repent and come back to the fold, to the church, okay, the church that gave them bread from the start. Okay, here it is. This is what he says.
You're watching the beginning of the collapse. You're watching people running for the exit. All of these guys are trying to plead. It's not string theory proper, we meant. Ha ha ha. We meant something related to string theory. Yeah, that's it. Hopefully somebody will come up with some money to hold a conference to get these people in the same room with the people they've tormented, whose careers they've ended, whose funds they've stolen, the stolen valor of actual achievements in real attempts to change physics. And wouldn't it be delicious and fun to see Michio Kaku, Ed Witten, Lenny Susskind, Michael Duff, Jeff Harvey, actually have to face people who know what they're talking about and have a discussion of what did we just do for 40 years. Nobody in their right mind gives a startup 40 years of runway with never a call with investors, nor even a basic MVP, most, minimal viable product.
Okay, so he's pretty upset. He wants vengeance. He wants to kill all these string theorists because they've bullied them for now, what, 20 years at least, since string theorists got muscle, and they're driving these guys out. And they feel that physics is dying, that physics is about to collapse and die. But he says the opposite. What's about to collapse is string theory, and we're going to go back to what we were doing, experiments and math, right? Because string theorists don't do experiments, especially, which is what Galileo says is what physics is about, math and experiments. So we have a problem because we started in the 17th century with math and experiments. They continue with math and experiments in the days of Einstein and Niels Bohr, right? And now they're getting away from experiments. They say string theorists aren't doing any experiments because they make no predictions and there's nothing to test. And so what's going to happen with physics? If physics is experiment, according to them, right? And this is where the problem is. Okay, and so what does Winey suggest for the greatest string theorist of them all, Leonard Susskind? Well, here it is. Let's see if you agree with him. Here goes.
No, I think that the prosecution should decline the offer from the good Dr. Susskind and say, no, you have 40 years of the destruction of your colleagues to answer for. You've chosen to be, words fail me, an asshole to just about everyone who came up with a competitor theory.
Oh man, he wants vengeance. He's upset, right? But he's polite about it, right? But he would, if he were the dictator of Earth, he would kill all string theorists. He would string them up. So what does Winey propose instead? Well, here it is. This is out of his website. He proposes something which he calls gravity unity, and it's got to do with obserververse. It's not the universe, it's the obserververse. He invented that word, right? And what is his theory, so-called theory? Talk about a 14-dimensional space-time. Talk about a crackpot, And talking about crackpots, let's apply the crackpot index to them. Here's John Baez's crackpot index. Let's apply it to Eric, and this could apply to almost all these people that I talked about today. Here you have 10 points for each claim that quantum mechanics is fundamentally misguided. And yeah, that's what string theorists are telling the quantum folk, even though quantum has been around for 100 years. Now it's fundamentally misguided because they're moving on to string theory. And it says 10 points for pointing out that you have gone to school as if this were evidence of sanity. That applies to all mathematical physicists. They say, oh, I went to school. Okay, you went to school and you can't tell me how... what causes a pencil to fall to the floor? So it's not evidence of sanity when they give you these ridiculous, irrational explanations for simple stuff like, light and gravity and so on. And then I like the next one. It says 10 points for arguing that while current well-established theory predicts phenomena correctly, it doesn't explain why they occur or fails to provide a mechanism. So you get 10 points off for that. And then he says in 26, he says, 20 points for talking about how great your theory is, but never actually explaining it. So, well, are we supposed to explain or not explain? If the theory doesn't explain and you're not supposed to explain, why is he saying that you didn't explain your theory? So he's got a little contradiction there. But, and then 20 points for use of science fiction works as myth or myths as if they were fact, which applies to quantum mechanics and general relativity, right? And defending yourself by bringing up real or imagined ridicule according to your past theories. In other words, string theories are laughing at this fellow, and he doesn't like it. He doesn't like to be laughed at, right? 40 points for claiming that the scientific establishment is engaged in a conspiracy to prevent your work from gaining its well-deserved fame. And yeah, these guys say, hey, my theories deserve their day in court, and the string theorists say, hey, your theory already died. We're not paying attention to it because we moved on to strings. And that leaves all these fellows who studied quantum mechanics in college like, holding the bag. What do we do now? Nobody's doing quantum mechanics. No one's carrying out the experiments or following up on the existing experiments. So they have problems all over the place. And of course, they're worried a little bit about their future, but they're also concerned with the fact that, where's all this going? I thought we were doing physics to understand the universe. And these people are saying, oh, what we're doing has nothing to do with reality. And they're all moving into this, this cottage industry known as string theory that has nothing to do with reality. And they're developing all this mathematical work, publishing papers on math that the public doesn't understand. They cannot translate their math into qualitative notions that you can understand mechanisms or causes or anything like that. So what is it for? Well, what's the point of doing all this irrational math? And this is where these people are concerned, and I think it's good. It's good because it means that there's a problem in the religion of mathematical physics. There's going to be a schism, or there is already a schism. Apparently they're throwing mud pies at each other, right? And so I think it's going in the right direction. Hopefully, we can only pray, right? Maybe if there's a God or Father Universe or whoever you believe in, maybe, just maybe, mathematical physics suffers a sudden death that it well deserves. Okay, I'm going to move on to our Neanderthals. We had a lot of questions on Neanderthals. A lot of people who apparently don't understand a lot of stuff related to Neanderthals. I don't know if they don't read or if they read the wrong things. Who knows what they read. But a lot of the stuff, I wonder where they got some of the stuff, And here it is. Let's go with the Neanderthals. We have one fellow, and he says the following. He says, a tiger wouldn't meet a lion because their habitats do not overlap. Obviously, if an animal is desperate and can't find a mate of their own species, they will mix, okay? And so he's got to look up a little more. He's got to read a little more. You'll go out there and read the following. It says, the two species ranges, talking about tigers and lions, right, are known to overlap in India's Gir National Park, though no ligers were known to live there. And that's in National Geographic. And then you find this other paper. It says the range of the tiger has overlap with that of lion, shepherd, leopard, snow leopard, and puma. Okay, so they do overlap somewhere on Earth, and nowhere in the wild do you have babies from two different species. And they're not maybe too far away. Maybe they could, like, you have a tiger and a lion in the zoo, and under special conditions, certain conditions, you can get them to mate and produce an offspring. The problem is that most of the time, those offspring, in fact, all the time, as far as I'm concerned, those offspring are dead ends. Okay, they have a baby, but the baby cannot have babies with another one of his kind. He's got to have apparently a baby with one of the original lions or the original tigers. In other words, it's got to be another tiger or another lion. You cannot do it with a ligon or with a tigon or a liger. Okay, that's the issue. And here's another fellow, and he says the following. He says, llama and camel can make a baby. African and European can make a baby. Yeah. Yet nobody says one race, the camelid race. Yeah, the issue here is that if the two animals are close enough, they're sister species. But if what comes out of there is an infertile baby, offspring, right? Then that's the dead end, and you can tell by that they're far too separated in time to be able to conceive something viable. That's the issue. That's why it's important, above all, to define the word species and the word race. People don't define; they don't want to do definitions, and they get into these types of trouble because they don't know if they're talking about two races of the same species or they're talking about two different species. Two different species means they cannot mate, meaning they cannot have viable children. Okay, they have infertile offspring. And races, same species, they can mate, but they just look different. Maybe different colors, maybe different morphology, whatever. That's how you have to define it. And if you have a different definition, hey, be my guest, bring it on. Okay, I want to know what a species is before you begin to talk. Like this fellow the other day said, Africans are a different species. than the Europeans. Absolutely, that cracked me up. Yeah, they're different species. Okay, and here I have, like brown and polar bears make Pizzlies. Okay, of course, if they can find one, they prefer their own species every time. They will never go without reproducing, although rather than mate with another species. Yeah, again, you got to define what a species is, and don't talk about this stuff unless you define the word species. That's the whole issue. You know, I mean, these people who use the word species simply because the guy looks differently. If he's black and I'm white, he's a different species. Okay, so here's the answer. Polar bears evolved from grizzly bears several 100,000 years ago and remain so closely genetically related that they are able to crossbreed. Okay, the only difference between polar bears and grizzlies are one's brown, the other one's white, more or less, but they're very close. You know, if they separated maybe 100 to 30 to 250, they're still not too far apart. They're still cousins. They might be able to breed even in the wild, probably, because they're not that different species. Okay, and it says lasting similarities, genetic similarities make the two bears biological sister species, right? And no, if they can mate, they're not species, they're races. Okay, or more or less approaching races. You approach species when you can't have viable children. And so they're very close to each other and very different than all the others. So you got to keep in mind the language. The language is absolutely important to communicate. People don't pay attention to language. You got to define what a species is, period. Okay. And one of these fellows again said, it still happens today that black females have to get a C-section when giving birth to a mulatto babies. Go laugh in their faces too. Make a video of that. I think it would be hilarious. Film that and then post it on YouTube. Let's see what happens. But you're not going to do that because it's racist. No, I have no problem with racism. I mean, I'm not racist, but I realize it's out there, right? It would have been even worse seeing a European skull's brains were bigger than today. You laugh, but you are just ignorant on the topic. Absolutely, I agree with you. I'm so ignorant on the subject, and that's why, you know, when I looked it up, I found no evidence of what you're saying about mulatto children. Here's what I found, more or less, you know, and it says the following. It says, race, ethnicity was significantly associated with the odds of a cesarean indication. All other race ethnic groups had higher odds of cesarean compared with white women. Compared with white women, black women had greater odds of fetal intolerance as an indication, while Hispanic and Asian women had greater odds of failure to progress. Maternal, neonate, and facility factors for cesarean delivery did not explain the observed disparities in cesarean delivery rates. In other words, women have problems, and you could say statistically some females have more problem, even by races. Some white women might have better chances than black women or than brown women or yellow women. It could happen, you know, maybe it's a statistical thing. That's not enough to draw these sweeping conclusions that this fellow did by saying, oh, all black women have to have cesarean sections when they have a mixed child. You can't generalize like that, but these people do that. So again, what can I say? You have to do more research. I am ignorant in the subject that you mentioned because I didn't find anything that supports what you said. But if you have something, put it out there. Bring the evidence. I want to see it. Don't just state it. Produce the evidence if it's important. Okay. Okay. Here's again. I think it's the same fellow. Explain to me the mechanism by which 1.2 meter tall African with black skin, afro hair, and brown eyes becomes a 2 meter tall blonde and blue-eyed fair-skinned European in 10,000 or 40,000 years. And again, he goes through this comparing these things. And the problem is, all of what he says there, you can read it later on, but all of what he says, where did he get all this stuff? Where does he read? He takes these conclusions as if they were, give me a second here. had a phone call there. So where does he get all this stuff? How come he comes with all these conclusions? This is where the problem is. His assumptions are wrong. And so, I can't answer all of what he said there because of what he's saying. Okay, let me get this out of here. Okay, and here we have a couple more. One fellow says, it's not science. Oh my God. Says, how do you know Neanderthals even existed? Some people are questioning even that. You show them these heads, they found them in a certain layer of the rock, and they wonder, how do you know they existed? So what is that? I mean, you have to make sense of what you find in the middle of the rock, okay? And so this is what's incredible about these people, that they don't understand something simple. This is just pure ignorance when they say something like that, okay? Now, if they're trying to be funny, okay, that's fine, but, And yet another fellow, he says, Bill assesses scientific theories on whether a scientist has been in the media or not, and therefore groomed by the elites. Because I said that this fellow, was being groomed since 2007, Svante Pavo, right? And he says, QAnon shit. Politicians don't give a shit about Neanderthals. What is he on about? Anyways, the issue there, the issue with the Neanderthals, is that it's not about Neanderthals. When this guy was being groomed, he was being groomed for DNA, not for Neanderthal. He's not a paleontologist. He's a geneticist. So when he was being groomed, it was all about DNA. They were trying to push DNA, and the fact that they were using DNA for cold cases in the police and so on, and they created a big my God. Okay, so here we have these are the some papers that a paper that was written says Neanderthals and modern humans diverged 800,000 years ago. This is more or less what everybody more or less accepts, right? 1 million years ago, Erectus fire. 800,000 years, maybe Heidelberg appeared, perhaps antecessor. 450 to 40,000 years ago, we had the Neanderthals, and humans appeared maybe 300,000 years ago, and we're still alive today. But you can see the oh my God. I guess they're gonna be calling me all day today. Okay. Anyways, throws you off. Okay. Anyway, here's the official Neanderthal empire, the way they think it happened. Okay, where Neanderthal lived, and you can see it's quite extensive. In fact, it went all the way to the Middle East and all the way maybe even to China, for all we know. And I think this is wrong. I think this is totally bunk. And the main reason is that the Neanderthals that were found in Kibara and Tabun were not Neanderthals. Okay, if you look at the bones, they're different than the classical Neanderthal. So my map looks a little different. Looks more or less like this. Here it is. Okay, the orange part, that's not part of the Neanderthal empire. I'm saying the Neanderthals only were in the yellowish greenish part there. Okay, so these people simply made the every bone that they found out there made it Neanderthal. Okay, let me get rid of this here. I'm just saying that the Neanderthal empire was not that big. Okay, not as they were in Europe. They had no reason to migrate to Asia or to Africa. They stayed there. It's us who migrated to their lands because we were following the herds. Okay, and they were also cold weather animals. They're like a polar bear. I mean, Polar bears don't go to the equator. It's the other way around. If anything, if there's food in the north, people from the equator will put on some clothes and go to the north, right? So if anything, bears will migrate north if there's food there, but not the other way around. Polar bears have no reason to go to the equator, especially if they are used to the cold and hunt seals or whatever they hunt up there. So no way. Neanderthals never ventured south to Israel or Iraq, and I think they never went east either. I don't think they ventured that far from Europe. Okay, but again, those are assumptions, and again, I have no solid evidence that any of the bones they found in the Middle East or in the East were Neanderthal. Okay, so here we have the genealogy of our species, you could say, of our lineage, not our species, but our lineage. Maybe Erectus started 1.8 million years ago, and it went all the way maybe to 800 and 900,000 when you find maybe a missing link known as antecessor. From there to maybe 750 to 400,000 years ago, Heidelberg. Then around maybe 500, 450,000 years ago, we have the Neanderthals. And parallel to that, in Africa, you have humans developed maybe around 200 to 300,000 years ago. We're the latest creature created by Mother Nature. And so that's more or less what I work with. Okay, you don't have to agree, and the dates are not ground in stone, but that's more or less what I work with. Those are the dates that I'm working with. So if you wonder where I get my ideas, well, that's what I work with. Now, someone can say, Bill, you're wrong. Let me show you something else. Okay, could be. Maybe my assumptions are wrong too, but that's what I work with right now. And so we did have a common ancestor, and this fellow Lowry, he wrote a paper, and he says that the reason we still have some Neanderthal DNA with us is that we had a common ancestor all the way back to antecessor or maybe even Homo erectus. That's why we only have 2.5% Neanderthal DNA. Oh my God. So anyways, they say that that's the reason we have commonality with the Neanderthals. Okay? And if you look at the technology that we used, it was different also. This is more or less a summary, right? But Erectus Heidelbergs, they used this Chilean technology, which was just banging with stones. They could grab a big stone, they killed something. That was about it. There were no spears at the time. Spear wasn't invented. Okay, and when you get to the Neanderthals, you get the Mousterian technology, which is when they chip off flakes and make something sharp. And eventually they even attached it to a stick, was known as hafting, and they used it as like a axe, right? And then we used the same stuff, by the way, but then eventually we moved to the origination, and what it is we started using bones as weapons, like the antlers of a deer or whatever. So technology advanced like that. That was ancient technology, how it advanced over time. Okay. And yeah, here you have the Scheningen spears. They found them here in Germany. They date to about 400 to 450,000 years ago at most. They believe they're Neanderthal, and you can see that they're just sharpened pieces of wood. And these were probably the first spears. Maybe, there were spears before then, but wood doesn't preserve very well. That's the issue. It doesn't preserve well. And so stone, if you see like an axe, like a sharpened piece of stone, then you would know that they had a more advanced technology. But no, what you find 400,000 years ago is wood, and very little of this, you won't find much. Means that they probably used some of these sticks as weapons, okay? And that's maybe how they hunted originally. And this is how they attached eventually, the what is known as hafting. They attached the spear head to the spear. And that's how technology advanced. So one of the ways they know that there were Neanderthals and humans and so on, and where they were and so on, is through the weapons. They look at the weapons, they say, oh, this is Acheulean, it's very ancient. Oh, this is Mousterian, that's Neanderthal. And that's more or less how they determine a lot of these things, when they don't find any bones, right? Okay, and the funny part is when they have these Neanderthals dressed in clothes. And you'll see that all the time. They dress all these Neanderthals in clothes. And you see pictures like this. You know, why did they dress them up? There were no clothes. You know, Neanderthals never used clothes. You don't find any needles. You don't find any evidence of clothes. Any piece of cloth lying around just by sheer coincidence, buried with Neanderthal or whatever. You find none of that at all. Okay. Now, of course, clothes don't survive. We know that. But, I mean, the point here is that they had no reason to use clothes. Their ancestors were the Heidelbergs, who had as ancestors the antecessor or Homo erectus. And those were already in England. And there were no clothes in the days of Homo erectus. How did he live there? He lived barefooted. He lived like a monkey. What I think it was a woolly monkey, a woolly man. And here you have another picture. You know, these are things that they show you. They show them all dressed up. This is so funny because, you know, there were no clothes at the time. They hunted these big animals. They hunted them barefoot. And they have them sometimes with sandals or whatever. Yeah, or they don't like nudity, I guess. I don't know. No, this is the way they hunted. Okay, here you have a picture. I made most of it, okay? And they were nude. Okay, and I think they were woolly man. You know, they were hairy. But again, we don't know. We've never recovered any tissue from the Neanderthals. Okay, and so what can I tell you? None of these guys understand very well what they're talking about. They have to do some of this research, and you got to look at many things. You got to look at the homeland. You know, their range. How far away did they travel? Okay. And Neanderthal was a localized guy. He was a sedentary guy, more or less. I mean, he did migrate, but, you know, maybe from cave to cave. And I suggested the other day how they could have reproduced. And one was by attacking another Neanderthal and killing him and taking all the females. That's one way. Another one was, you know, the Neanderthals, boy, girl, they leave the clan and they form their own, you know, house, they find their own cave and continue reproducing. And another one is, again, you know, you have these not only wars, but you know, you have maybe solitary encounters that could have happened as well. So there's different ways that they reproduced and they, you know, the population advanced, but under no circumstances was a Neanderthal a friend of another Neanderthal. They were all enemies. The worst enemy of a Neanderthal was another Neanderthal because there were no humans around at the time. So that was the worst enemy. And then when humans came around, guess what? You know, we were not friends either. We were all enemies. In fact, we were enemies amongst ourselves. Humans killed humans. So people think out there it's all love and kisses. It's the other way around. It's war. So you got to have that. Then you have the question of dress, you know, how did they dress? Where they dressed? And if humans were dressed and Neanderthals were not, believe me, they would have recognized each other as different species. Okay, and, you know, you don't. A Neanderthal is an animal in the wild, and he looks at something that's dressed. He says, "What the hell is that?" You know, that's a different thing. He's not going to sleep with that. And so people don't understand these basic things of anthropology. And I think that they should do a little more research and a lot more thinking. Okay. Anyways, we'll see you next week, and I'll talk to you then.